So here, okay. Shall I mute my video, Nitya?
Yes, ma'am.
Okay. Okay. So here my topic is machine learning in data analytics. Okay, so here actually this is combination of two titles. One is the machine learning, another one is the data analytics. So first I'll start with this data analytics. First you should understand, because most of these participants are from research students, research scholars, and some of my students also joined in this, and some are doing research. Okay. So first I will start with this concept of data analytics, then I will connect this data analytics with this machine learning. Okay. So on seeing this image itself, you can identify here a machine is there. Okay, a machine is there, and it is started to looking for the data. Okay, so the looking for data, so it's going to do something with the support of some algorithm and doing some concepts on this data. Okay, so for that, first you have to understand what is data. Okay, so nowadays you all know data is everywhere. Okay, in everywhere. Okay, during the COVID time, started to take the usually the people come and take the that is a survey on how many people are there in your house and how many are affected by this kind of symptoms. Okay, so this is a kind of data. Then even our RT-PCR, it is a kind of data. And everyone in the past 2 years, we are almost in social media only. Okay, in the social media platform, we are uploading our pictures, images, and downloading some videos, audios. So those are also known as a data. And in some time, when we go for online shopping with Amazon or some other very popular online shopping websites, okay, before going to place an order, immediately first we will go and check that product reviews, okay, then we will see the feedbacks, then only once we satisfy with that reviews and feedback, then only we will go for the ordering. Okay, that is also known to be a kind of data. Okay, so now data is everywhere. So that's what the data is now considered to be. It is a kind of new oil to this digital economy. So here, if I ask what is data means, you can answer me. It is a kind of information. Okay, that is the answer. Anyway, everyone will reply for my question. But here, it is not only information. Data is not only information. It is a kind of graph also. Okay, in this previous picture, some graphs. If suppose if you are watching any news channel, they're mostly if they discuss any kind of issues, any election results or gold rates, petrol prices or anything, they will show it in a form of graphs only. Okay, so that is also considered to be a data. Okay, graph also a data. Then some kind of measurements. Okay, measurements, a heights, a weight or something. Okay, that is also even in a kind, it is a data. Then some kind of observations. Okay, suppose in a particular area, if suppose they want to take survey and how many people are affected by the COVID or how many people are completed the COVID vaccination. Okay, so some kind of observation also there. Then some facts are there. Okay, that is also considered to be data. And some numbers. Okay, number of old people in a particular area, number of children in a house, it is also considered to be data in a quantities. Okay, some quantities. So these are the various forms representing a data. Okay, so that's what in our data is categorized into two types. One is quantitative, another one is qualitative. Okay, this is the first one and this is the second one. So in the quantitative is you also I understand that quantitative is nothing else. It is a numerical representation. Okay, it is a number. Qualitative means it is a descriptive. Okay, so in descriptive here you can say that this vehicle is in a red color, and then the skin, okay, skin of this animal is very soft. Okay, that way you can describe it. Okay, that is a qualitative data. In quantitative, it is in a number form. Okay, in a number form, here you can use, as a computer science, you are all familiar with that. You can use a number in a whole number. Okay, as a discrete form, or you can do it in a continuous form also. Okay, so in a discrete numbers, they are usually counts are considered to be a discrete number. Okay, number of children in a house. Okay, number of trees in a park. Okay, they are known to be the discrete numbers. Whereas continuous numbers are they are usually measured. Okay, that is like the temperature. Okay, the humidity. okay, the height of something, the weight of something, okay, then gold price, okay, likewise they're measured means then it will be a continuous form, okay, continuous data. So since this concept of data is everywhere, based on that, okay, leave it, but naturally to grow in your business, not only in your business, even in your life, if suppose if you are a student, immediately what you will do, you will start it. Suppose you want to go to your next level, okay, next level, then immediately you start to analyze, can I go for higher studies, or can I go for a job? In that kind of analysis you will do, okay. In the same way also in business also, the business people, they try to analyze how to improve how to reach the next level in their business. In that way they will start to do some analysis, okay. Now you can connect this data, okay, data is everywhere, all kind of data are available. Now a kind of naturally each and every human are having their analysis concept. So now combining these two concepts, here we are having this concept of data analysis, okay. Data is available, analysis is naturally a nature of a human, okay. So data analysis, one of the popular terminology nowadays we are using with the field, okay. So in this data analytics, okay, so that's what, but anyway we have to define that. We have to define what is data analytics, okay. So this data analytics, already you all know the data in a two form, one is quantitative, another one is qualitative. So this data analytic means the set of quantitative and qualitative approaches. In both way you have to approach, because some data may be in quantitative form, number form, some data may be in a qualitative form, okay, in a descriptive form. So you have to develop both the approaches, analysis approaches, okay. So it is a set of quantitative and qualitative approaches for deriving valuable insights from the data, okay. The data is there, okay. From the data you try to extract something, okay. So for deriving valuable insights from the data, okay. So qualitative and quantitative approaches, and this is your objective, okay. This is your aim for developing this concept. So for based on that, it involves many processes. Data analysis, analytics involves many processes, okay. The first one is, okay, the approaches. We are developing these approaches for extracting the data and categorizing it, okay. From the available data, you will develop some approaches. The purpose is, using that approaches, you try to categorize those data, okay. You try to categorize those data, okay. So in a particular area, if you have taken some census value, then using that census data, you try to understand what is the income of that, average income of that area, or what is the average age of children in that area, or how many schools are available in that area. So in that way you have to categorize it, okay. So that is the one concept. And next one is, I told you now, for deriving valuable insights from the data. So that what is that valuable insight? They are nothing else but you try to derive the various patterns or some kind of relations or connections and other such valuable insights from it, okay. So from there you try to find out some patterns. Is this kind of pattern is available, whether this area is keep on affecting by some fever or keep on affecting by some cough. In that way you try to find out some kind of patterns there, or some kind of relations or connection in that. Maybe in some area, most of the people, most of the house people may be in a foreign country. So in that place something may be happen. Then you can try to connect those concepts, the foreign visit concept, you can connect with that, okay, from the data. So that kind of concepts are comes under data analytics, okay. So first you have to understand where is this, okay, in which platform or which field we are doing this data analytics. Actually, data analytics, see this picture B. So in this data analytics is nothing else but it kind of a tool, artificial intelligence tool or a robotics model. Okay, so these three are similar, okay, data analytics tool or artificial intelligence tool or robotics models will develop with the support of any machine learning algorithm, or we may go with artificial neural network models, or further we can use this deep learning models, okay. These are some of the tools and techniques used for doing this data analytics, but all these comes under this, okay. This data analytics, AI, robotics all comes under this data science field, okay, in data science. But data science is almost nowadays everyone are telling that this data science is a multidisciplinary approach, but no. It comes under only computer science field. Okay, those who are very well with this computer science, they can, this is the subdomain of computer science. Okay, so in this, already told you, this artificial intelligence, there may be several, so many methods, so many systems, expert systems, so many rule-based systems, knowledge-based systems are available. In that, machine learning is a subdomain, it is a subset. In that, deep learning is there. But for data analytics, okay, we can use all these techniques for doing this kind of data analytics. These are some of the popular methods in data analytics. First one is data cleaning, okay, because I already told you, so many data available for you. But you have to do, so as a pre-processing, you have to do this data cleaning form. Okay, data cleaning means there may be any unwanted data may be there. For example, while doing this survey, okay, while doing the survey in a particular area, if you're, you will take the data and you will put it in a tabular form. Okay, maybe in a Excel sheet. Okay, in a Excel sheet, for example, it's suppose a field under. Okay, field under, if a number of children in a house, okay, number of children. Here, for each house, the entry may be either 2, 3, 5, 6, okay, 7 may be also acceptable, okay, but nowadays it's not acceptable, okay, 7. But sometimes, if suppose a particular entry is made as 100 means it is not possible, okay, that is considered to be unwanted data, okay, it is not possible. So there you have to clean the data, okay, you have to replace data because you completed the survey, but anyway you have to replace it, okay, so that kind of data cleaning are required, okay, that is one kind of data analytics. And second one is transformation, okay, transformation means here, there are so many domains are there to work with the data. Okay, for example, I can take the image data. Okay, for image data, those who are already familiar with this image processing subject, you can understand me. Image data, usually we analyze the image in spatial domain. Okay, here image is represented as a matrix of intensity values. Okay, in the matrix you'll have rows and columns. Okay, it's a spatial representation. First row, second column, 15th row, 13th column. Okay, so the spatial representation is there. It is considered to be spatial domain. But in some application, for some application, we cannot analyze this image in a spatial domain. You have to convert this image into a frequency domain. Okay, so you have to convert the image intensity into a frequency. There you can do the analysis. Okay, so that is a converted from one domain into another domain. I'm speaking into image processing. So here in conversion from one spatial domain to frequency domain, it's considered to be the transformation. Or I think those who are completed a computer graphics, you can familiar with this transformations. Okay, geometric transformation. So geometric transformation, the very popular 2D geometric transformations are translation, scaling, rotation. For some kind of analysis, the data may be, that image has to be rotated and then you can apply the some algorithm on it. Okay, so these are the some kind of transformation we have to do with this data analytics form. Okay, then data exploration, hypothesis testing, and visualization. These are some more additional methods used for the data analytics. Nowadays, this data visualization is very popular. If somebody is really interested in involved with this data analytics study or data analytics jobs, then you can go through this data visualization concept. It is some kind of, that is some very interesting portion like our multimedia. Okay, so you can involve with this data visualization. Okay, and these are the 6 steps involved with data analytic process. Okay, 6 steps involved in a data analytic process. Am I audible?
Yes, ma'am.
Okay. So in this data analytic process, in this 6th step, the first one is data preparation. Okay, data preparation. So now you have to decide your domain, in which domain you are going to work. Okay, so for that particular domain, you have to collect all the related data. Okay, all the related data, and for that collection, you have to first do the design, and you have to do some experiment with that. Then here experiment in the sense you have to design in what way you are going to collect the data and how you are going to collect those data. Okay, whether all the data available with that are in a perfect format, okay, in a expected format, everything you have to decide. Then you have to formulate the problem also. Okay, for what kind of problem you are going to collecting this data. Okay, so everything you have to do in step 1. Okay, that is known to be the data preparation. Suppose if you are going to work with any agriculture based applications, there in what kind of product you are going to work, whether you are going to work with fruits, or you're going to work with the vegetables, or you're going to work with plants, or you're going to work with the trees. Okay, so based on that you have to do your data collection images. Or if you are going to work with any healthcare applications, there in what kind of healthcare you're going to analyze. You're going to analyze the diabetic patients, or going to analyze the COVID patients, okay, or you're going to analyze the nutritional status of a particular area. Okay, based on that you have to do this data preparation. So that one is the first concept. Usually this is similar to our system analysis concept. Okay, so data preparation. Then after the data preparation, once you complete this, then you have to explore the data. You have to start to analyze the data. Okay, so for doing this data analysis, and even you can apply this data visualization also, and these 2 steps are known to be data analytics. Okay, I will tell what are all the concepts used with these 2 steps in my next slides. Okay, these 2 steps are known to be data analytics. Okay, then after that, once you analyze, your data analytic portion is over, then now you are very much familiar with your data. Now you start to classify your data based on your expectations. So what kind of pattern you have to extract from the data, or what kind of description you are expecting from your data. Okay, for that purpose you have to do the classification and clustering. Clustering means grouping. Okay, either you will do the classification or you do the clustering concept. For classification example, if suppose if you analyze a particular kind of fruit, then you will start to whether the fruit is in a good form. Okay, it is in a good form or not. It is not bad. Okay, in that way you can classify it, or you can cluster it. In the same fruit there may be several varieties will be there. Then you have to group the varieties of the fruits. Okay, that is known to be the clustering. Okay, then after did this, then you will display. Okay, based on that clustering, it will produce the results. Okay, that is, it will predict something. Okay, predict your objective. Okay, so this clustering and predictive analysis, grouping and predictive analysis, step 4 and 5 are, for that purpose we will use the machine learning algorithms. And finally, once the machine learning algorithm is defined, a best model will be produced. Okay, so that model will be used to assign our AI model. Okay, it is a final AI model. So once you have submitted your data, you selected your data, then in between you are doing 2 major steps. One is data analytics, another one is the machine learning algorithm. Then finally it will produce an AI model. Okay, so in this, first we are going to discuss about the concepts used with this data analytics. Okay, so for that, here these are all the steps involved in data analytics. One is you have to get the data. I already told you have to get the data. Then you have to start analyze the data. Okay, first you'll get the data, analyze the data. At the same time, while analyze the data, you can use some kind of visualization concept also to analyze the data. Already told you, in news media and all, they will use some graphs for analyzing the data. Then you have to publish the data and consume. If there's further needed, then you can consume the data. Okay, so here I'll give one example. I will explain this concept with an example. Here, this is the census data collection. Okay, census data collection. In this, here for getting data, first you have to fix the field. Okay, so these are all the field from census data, starting from, okay, collecting details about a house with a house number, husband age, wife age, husband income, wife income, number of bedrooms, electricity units, gas, number of children, internet connection and mode of the connection, house owned or rented, then what is the speaking language in the house, and decade of, that is house age, decade of house built. These are some of the fields. Now you design this. Okay, I told you, for data preparation, first you have to design this. Then you start to collect the details in a area wise, okay, in a particular area. This is a sample sheet. Mostly the data collection nowadays, we will be present them into a Excel sheet, okay. We will make an entry because you all familiar with the Google Forms. Whatever you give an entry into a Google Form, immediately you can convert them into a Excel sheet, okay. So Excel sheets, CSV files are one of the very popular data sets, okay, data set formats for the machine learning algorithm. So then that's what everything should be created in a form of data sets, textual data. I'm telling about this, okay. So in this census data here, you have to next after that, I told you, in the step 1, after did this experiment, design your data, then after did this experiment, you have to formulate your problem, okay. So after this, I have to formulate my problem. So here I formulating 3 problems, okay. Based on this example, 3 problems are formulated. Problem 1 is, here in the census data, I want to know the maximum, minimum or average age of a wife, okay. This is one statement. And second statement is know the median, quantile, variance and standard deviation of the income, husband income. And third one is find the frequency of number of children and number of bedrooms, okay. Find the frequency of, because maximum in a house, they may have a 1 children or 2 children or 3 children, that's all. So they want to know, okay, the frequency of single children, the frequency of 2 children, the frequency of more than 2 children, that they would want to know, okay. So for this kind of analysis, naturally we will go for a graphs, okay. You will put a bar graph, number of single children houses, number of two children houses and number of 3 children houses. A bar will be drawn for that, okay. So that is frequency, okay. Frequency is given as a visualization format. Whereas in above 2 statement, know the minimum, the maximum, know the median, for this and all, you will naturally use the statistical formulas, or that minimum formula, maximum formula, or mean, median, mode, variance, okay, standard deviation. Everything is based on the formulas will be, okay, used for that, okay. So for doing this, the solution is, first you will import the data, okay. You will import the data set. Data set is already available in the Excel sheet. Then you will perform the data cleaning. Data cleaning, I already told you, there may be missing data there, okay. And there may be sometimes no entry will be made for a number of children in a particular house. No entry may be made for a number of electric unit in a house, okay. Those missing data and all, you have to do some process to fill all those data, okay. Because after that you are going to develop a formula, okay. Formula will expect a number in each and every cell. It will not accept a null cell, okay. So for that purpose, you have to do this pre-processing. This is known to be the data cleaning, is considered to be the pre-processing, okay. This kind of pre-processing we can do in images also, okay. So here, if suppose you are collecting images from a particular classroom, okay, a student classroom, you are collecting the images, but the images, while seeing the images are not in good contrast, okay. If they are very blurred, okay, the contrast is very low. So before going to analyze that image, you have to improve the contrast, you have to enhance the image quality, okay. So that kind of concept and all known to be data cleaning or image pre-processing, okay. You have to perform some kind of pre-processing before going to analyze the data, okay. So first import the data set, then you have to perform this data cleaning or data pre-processing. After completing this, then you can use your solution, that is techniques to define your problem statements, okay. So for that, first find the minimum, maximum, average. Here you have to calculate the min, max and mean of the wife age, okay. This is the first one. And for your second statement, again, this is also a simple calculation. So calculating the median, variance, standard deviation of the husband income. But whereas for the last statement, find the frequency, there here naturally you will plot the data for the number of children and number of bedrooms, okay. This is given in a form of graphs, okay. So that's what I told you previously in data analytics. You can now once again you can see here in data analytics, you can exploratory, the data analysis or data visualization. Both the steps can be used here, okay. Analyze and visualize them, okay. So for doing this, okay, this kind of analysis, they can be 4 types of analytics are possible. One is the descriptive analytics, another one is the predictive analysis, another one is the diagnostic analysis, another one is the prescriptive analytics. Okay, so here we have to once familiar with this kind of analytics, because based on this only you will decide what kind of analytics you can go further. Okay, so in this descriptive analytics, okay, descriptive analytics is nothing else but you will have you work with your incoming data. The data will be there, then you will work with that and you will give some description based output for the data. Okay, on seeing all those data, if suppose for census data itself, you can write something. So in this area, in this particular area, since the income is in this way, most of the children are not going for the school because the family income is very low. They are in daily wages only they are doing, and like that way you can give your description based analysis output. Okay, then for predictive analysis means here based on your input data. Okay, the data is in your hand now, used to that you can predict something. This is mostly used with the agriculture for field. Okay, suppose based on temperature or humidity, up to today temperature, you can say that whether what about the weather report for the next 2 days and the next 3 days, and what will be do with that farmers with their farms. Okay, in that way a path in predictor for the future course of action can be given. Okay, that is comes under predictive analysis. And diagnostic analysis, here this diagnostic analysis, what it will do, it will take the present as well as past history also it will take, and it will do some diagnostic based analysis. Okay, I'll give this example later for this. Then prescriptive. Okay, prescriptive analysis is this type of analysis mostly on based on some rules and recommendation. Okay, in order to prescribe something, this will make some rules, some recommendation will be there. Based on that, they'll try to match the data and they will produce the output for that. Okay, this mostly happens with some popular organizations and all. Okay, prescriptive analytics. So for doing this kind of tools here, for this kind of analytics, there are so many tools are available in our computer science field. Okay, so these are some of the tools: Tableau, SAS, Hadoop, Python, Splunk, Spark, or SQL Server. So among them, the very popular are Python or Hadoop. These are the SQL Server. Okay, these are all the popular tools. Okay, here you have to decide, because here suppose if you want to work with machine learning based algorithm, in your hand you are having data, but you have to develop a machine learning algorithm. That is, you have to develop one artificial intelligence model for that based on machine learning algorithm. Then you have to work with this Python tool. Okay, Python is a kind of programming language. Okay, or if suppose you are having a big data analytic framework, you want to work with a kind of framework, you can go with the SAS and Hadoops. Okay, or R is also there. R is also for doing some kind of clustering, classification, visualization concept. R tool also available. Or suppose if you want to work with some query based, okay, query based analysis you want to work with, because the most of the chatbots and all, they are based on the query based interactions will be done in that. Okay, so in that places and all, you can use this SQL Server based analysis also you can do. Okay, so these are some of the tools. So you have to decide, okay, in which field you want to enter. Then based on that, you can use these tools. Okay, so here given first Spark is a framework. Okay, this is a real-time data analytics. It is a part of, I already told you, it is a part of Hadoop ecosystem. Then Python is a programming language. Okay, this is mostly used to work with the machine learning algorithms. And SAS is also an analytical tool. Okay, so this is used to work with a huge volume of data. Okay, then Hadoop is a popular big data framework. SQL is already all familiar with that. It is used for RDBMS based applications. Okay, Tableau is also, once again, it is used for work with business intelligence tools, and Splunk is a tool used to extract some information from the business data. And R programming, again, it is used with both the statistical computing and graphical applications. Okay, these are all the tools available for the data analytics. And this data analytic application, it is applied in several fields, starting from the finance, and data analytics in healthcare, marketing, human resource, IoT, okay, Internet of Things, and analytics for business. Okay, mostly these are related with the business oriented applications, but in this the healthcare is different. I will give an example for that. Data analytics in healthcare, because nowadays wherever you go, even in a small simple clinic, okay, immediately the patient details are entered into a computer, okay, entered into the computer. So that was the data collection in healthcare centers, okay. Any big hospital, multi-speciality hospital or clinics or anywhere, it is streamlined, okay, everything's entered into a system, okay, they are digitized, okay. So that's what this helps to improve the daily operation or patient care of the hospital, okay, because here everything is digitized, everything is recorded. The patient, as soon as he entered into a hospital, they can refer the patient past history, okay. Then the healthcare, the diagnostic, treatment planning will be improved based on the past history of the patient, or sometimes the symptom of the patient can be compared with the some other patient's symptoms, and based on that some treatment planning can be happening with the patient, okay. So this is the advantage of using data analytics in the healthcare system. So that's what this data analytic in healthcare system that will used for lowering the expenses and improving the patient care outcomes, because they're having the current data, previous data, data of the different patients, everything is available, okay. Then this analytical tool, easily they can take the patient data and compare with the previous data or anything. They can recommend diagnostic treatment planning. Everything is possible with the healthcare system, okay. So with this data analytic portion is over, given some concept on this data analytics. Next, I will continue with this machine learning algorithm. Okay, what is the concept of this machine learning and how this machine learning algorithm are supporting for doing this data analytics. Okay, till that, do you have any doubts? Okay. I will continue with this machine learning algorithm. So this is the machine learning. Okay. Nowadays, we are allowing the machines for doing everything by their own. Okay. So in the machine learning also, in our real life, there are so many examples for machine learning. One is the image. The very popular example is image recognition and speech recognition. Okay. Alexa and all very popular machines are okay nowadays available with text. And image recognition, face recognition and all available, and medical diagnosis, statistical arbitrage, predictive analysis. Predictive analysis, I already told you, in agri department and all, agriculture and all, we can use this very well used, and we can support our farmers using this predictive analysis. Even in medical field also, the predictive analysis will be very much helpful for the doctors to take their treatment planning, okay, and the extraction. Okay, these are the real life example for the machine learning. So in that, the image recognition, okay, image recognition, I already told you, here image is a digital image. Digital image is in the form of, once again, here it is a form of rows and columns, okay. Whenever you work with a data set, they may be in a tabular form or they may be in a row and column of a matrix form. In table also, you'll have a row and column format. In image matrix also, you'll have a row and column format. But here in this row and column of having intensity of pixel values, okay, intensity of pixel values represented in a row column format. That intensity may be represented either a black and white image or used for represent a grayscale image or used for represent the color images. Okay. So here this image recognition, here you all familiar with the X-ray images. Okay. So when you take an X-ray image, this machine learning algorithm, this will try to, okay, we will develop an algorithm to understand whether the cancer cells are available in that images. Okay. Suppose a cancer patient is imaged by this, then this algorithm, we will develop an algorithm to identify the kind of cancers available with the X-ray image or not. Okay. That is one example in image recognition. Okay. Try to recognize the X-ray, whether the X-ray is a cancer X-ray or not. not. Okay, I think you understand this point. And next kind of image recognition is tag a name for a photographing space. Okay, tagging, it's mostly you are using this concept with your mobile. Okay, in social media it will automatically tag a name to a particular photographed face. Okay, and this is face recognition, comes under the face recognition. If suppose in our university, if you are having a database of, data set of all the students' pictures, then we can use this application, image recognition application. If suppose for somewhere, if you are in a camera, if I taken people for putting the attendance, upon seeing the face itself, it will mark the attendance. Okay, it will tag the registered number with the face and it will give an attendance on that. Okay, so this is one of the best example for image recognition in a educational institutions. Okay, then recognizing handwriting by segmenting the single letter, into a smaller images. So handwrittens maybe you can take a photograph of that, or you can convert into a PDF. Now the particular machine learning algorithm, what it can do, it can separate the handwritten words into a characters and combine them and trying to understand those words. Okay, so this is also, because here in handwritten will be here your question, nowadays you all very much familiar with that, because most of you did your exams in online. Okay, in online exam, after completing your written process, you will take a photograph and you will upload that. Okay, so those uploaded, here so many machine learning algorithms are, those uploaded handwritten PDFs are, they can be easily converted into a soft copy of the answer script. Okay, then they may be used for the correction. Okay, so these are the some kind of image recognition. And medical diagnosis, machine learning can help with the diagnosis of the disease. Okay, diagnosis of the disease. Here I already told you, even here, it will recommend a treatment planning. Okay, it will recommend a treatment option. Real world example is, it can recommend a treatment option based on the chatbot process. Okay, a doctor may ask a question, a patient can give some answers based on his symptom. Okay, doctor may expect some symptom from him, he can answer for that. By combining all this, then they can go for it can recommend a treatment option. Okay, or using this images, oncopathology machine learning to recognize the cancer tissues. Okay, this is, they can understand, whether in this X-ray or in the CT scan or MRI scan, any cancer tissues are available. Okay, they try to understand that. Okay, so these are the some examples of medical diagnosis. So machine learning in medical image analysis, because our group, we are doing research in medical image analysis in our department, and past 2016 onwards, we are doing this 15 years we are working with this medical image analysis. Okay, so in the medical image analysis, here nowadays, see the step 1. Okay, in the step 1, I think most of you familiar with that. This is an MRI scanner. Okay, MRI scanner or CT scanner. Here inside a room, it will be placed. A patient is placed on inside the scanner. Then in the outside, with the support of the monitor, with the support of a computer, the images will be taken. Okay, but nowadays, previously when we go with the X-ray and all, only one image will be produced for a patient. Okay, if you go with your any fracture, hand fracture or leg fracture, for anything, they will take only one picture, one image will be produced. But nowadays in MRI and all, for a single patient, it will be produced multiple images. Okay, here the multiple means it may be hundreds of images, sometimes thousands of images also it can produce for a single patient. I am telling, thousands, hundreds and thousands of images will be produced by the MRI scanners. Okay, so here what the doctor has to do, has to look for all the images. Okay, he sit and look for all the images and analyze all the images. Sometimes he may be interacted with other experts also, and they will derive the final solution for this patient. Okay, whether they can treat the patient with the medication or they can take the patient for the surgical process. Okay, so this kind of. So thousands of images are available. This is the brain image, brain image of a patient. So in a brain data set, usually brain, you all know that it is a kind of 3D object. Okay, brain is a kind of 3D object. Okay, so in this 3D object, in the single image is not possible. In the 3D object, each and every location should be imaged separately. Okay, so that's what it is. This data set is, brain data set is known to be the brain volume. Okay, so this brain volume is stack of 2D slices. Okay, object of here we have to go with 3D, but here it is taken, the images are taken into a 2D forms. It is a stack of 2D slices, 2D images. Okay. So here, previously, and here, and using some additional technology. Here, these are all the advanced technology to display all those images, and then a doctor can go and interact with this technology, and he can analyze the patient status. Okay, so that's what the doctors is challenging here. I can learn everything automatically from experience. Okay, he is challenging the machine. Can you learn? Because previously, when we introduce artificial intelligence systems, they are just based on the command accepted systems. Okay, the human will give some command to that, to it will do. That's all. Okay, based on some command or based on some instruction, it will follow. That's all. But here, the human is challenging him. Can you learn? But nowadays, using with the support of latest technology, the machines also ready for learning everything as human do. Okay, yes, I can also learn from past data with the help of machine learning. Okay, so the machine can also learn everything with the help of this concept machine learning. Okay, so this is it is a new kind of science. Okay, that is a science of training machines to perform human tasks. Okay, science of training machines to perform the human task. So this is known to be artificial intelligence. Okay, this science is known to be the artificial intelligence. Okay, so the main objective of artificial intelligence is the automation. Okay, to try to develop an automation. So in automation means in the images, what we will do, we'll try to extract something from the image, and we'll try to analyze the image and understand some useful information. Okay, in a medical field, say these doctors, they are displaying images on the screen. Okay, suppose they are some neurological doctors, okay, neurosurgeon or neurologist. What they will do, they try to, from the brain image, they try to identify a kind of tumor, okay, where is the tumor available in the brain. Then they start to, okay, they try to extract the tumor. Then they start to analyze the form of tumor, grade of tumor, whether the tumor is a very simple way, we can remove it, or it may be in advanced state, in which state the tumor is. Okay, so that kind of analysis they will do. Then using that, they will go for the further treatment. They will understand the information. Okay, so for that, they will use a single image or they will use a sequence of images in artificial intelligence. Okay, so for that purpose, we are using this automation we are using. But nowadays, instead of this human, okay, they are trying to replace, okay, they are trying to replace the human with the machine. Okay, they are trying to develop a machine for doing all these things. Okay, for doing the extraction, analysis and understanding, everything will be done by this machine. So for that purpose, they are developing the concept of learning to machine. So machine learning. Okay. This artificial intelligence in medical image analysis mostly used with the two field. One is the radiology field, another one is the pathology field. Okay, that's it. I don't want to explain this much in this. And one more thing, they will be used in, okay, this artificial intelligence is used with the robotic surgeries. Okay, robotic surgery in medical field. Okay, so here this is the robot. Okay, this robot with the camera and it has its arms, okay, with the medical instruments, the surgical instrument. Patient is placed on a table. Here, actually, the real surgeon is work with this computer console, because here with this camera, it will take the images of the organ that will be passed to this console, okay, this computer to the doctor. Then based on this, sometime while passing this image itself, this in this robot is suppose it is worked under the machine learning concept, it will itself learn something. Okay, it will itself identify where is the cancer tissues are available in the abdomen. Okay, where is the cancer is available in your liver, or suppose you work with some kidney tumor, then it will identify. It will take the photo of the kidney and it will identify some kind of tumors are available with the kidney upper space, okay, or side and anywhere. Then it will mark it and it will send this machine learning algorithm is there, means it will mark the tumor on the kidney and it will send that photograph to the doctor. Okay, now the doctor, it is very easy for him because some informations are fed by the machine, not robotic. Then he can direct the robots to remove the tumor based on the information given by this machine. Okay, so this is known to be the robotic surgery. Okay, this is a real life robotic surgery used within some foreign hospitals. Okay, robotic surgery. So here, that's what this machine learning is. It is nothing else, but it is subset of artificial intelligence. Machine learning is the subset of the artificial intelligence. So the main concept is this machine learning is used to do development of algorithms. Okay, keep in mind this machine learning used to develop the algorithm which allows the computer to learn. Okay. It will develop an algorithm because mostly you all understand what is an algorithm. Algorithm is a step-by-step procedure written by a programmer. Okay, we will write the algorithm and we will give it to a system. That's only we will all know. But here, the machine itself, it will develop an algorithm by using the learning process. It will make a computer to learn. From where they will learn? They will learn from the data and experience of their own. Okay, from the input data. They are given some data to the computer. No, from the data, they themselves learn and they themselves develop the algorithm. Okay, and they will test the output. If they satisfy with the output, they will proceed with the algorithm. Otherwise, they once again it will go and it will fetch the data and it will change its strategy in some way and again produce the results. So that is known to be the experience. Okay, experience of their own. Okay, so this term machine learning was first introduced in 1959 by Arthur Samuel, because you have to first understand, that is, you have to know this concept and all. Whenever a new term comes into our computer science, you have to know this person who is introduced this one and which year that concept was introduced. Okay, machine learning was introduced in 1959 by Arthur Samuel. Okay. Then here, and this is artificial intelligence. The machine learning is a subset of artificial intelligence, and one more, deep learning is nowadays very popular. That is the subset of the machine learning. Okay, so this machine learning, the main objective of machine learning is it will enable some machine. Okay, it will enable a machine to automatically learn from the data and improve the performance from experience and predict things. These are the three concepts. Okay. But all these three will be done by the machine. Okay, it will enable a machine to learn from data, improve the performance from experience, and predict things without being programmed. Okay, I think those who are not those who are afraid of programming language, it is a happy news for you, because no need to write any program for this machine learning algorithms. Okay, so here mostly you will deal with the kind of data only. Okay, a kind of data, how to collect the data, how to pre-processing the data, how to clean the data. In that way only you have to concentrate. Whereas the rest of the things, it will be done by this kind of machine learning algorithms. Okay, the model will be developed. Okay, so this is the improvement from AI, then machine learning introduced during 80s, 90s, 2000, and now the popular is deep learning. Okay, so here this is a picture which we are using in our research. It is a human brain. Okay, so in the human brain, this portion, it is marked by this red color border. Okay, this portion is considered to be the brain tumor. Okay, so when a doctor sees this picture, here actually this border is given by us. Okay, so in the original picture, border will not be available, but in order to give an example, I put this border. Okay, so leave it. So while the original picture is given after taken this image, when the neurologist come and view this picture, he can easily identify this portion. Okay, and he can arrive for this concept of this patient is affected by the brain tumor, because this region is affected by the tumor. Okay, for this purpose, but anyway, for in our artificial intelligence field, okay, we have to develop a tool to identify this automatically, because artificial intelligence main concept is automation. So we have to develop a tool for automatically identify this brain tumor portion from the human brain image. Okay, human brain image. So this is one of the very popular tool, artificial intelligence tool in medicine available. The tool name is Brain Scan. Okay, so this tool, for this scan, whenever you select a patient images, these are the images. Already I told you, if for a single patient, it will produce multiple images. Okay, so many images it will produce. All those images, when you give these images as input, so as a data, then immediately the tool will analyze all these images and it will produce the results. Okay, it will give the interpretation, that is classification result, what kind of brain disease and how much percentage it is applicable, available with this brain, it is given in the percentage. Okay, there are so many brain diseases are available. These are the names. Okay, I may be a little bit tough for you to understand these words. Okay, starting from epidural, intraparenchymal, intraventricular, subarachnoid, subdural. Okay, there are so many brain diseases are there, but this tool, what it will do, for each kind of brain disease, it will analyze the patient data and it will give the percentage possibility of the disease with this image. In a percentage it will give. Okay, so if you see this here, the 94% is with the subdural. Okay, disease called subdural is possible with this image with 94%. Yes, it is possible because this yellow color, this is some abnormality. A kind of abnormality happens in this location. Actually, in the border location is known to be dural location. Okay, the subdural, there is some abnormality. So that is mentioned by, now you can see, it is beautifully mentioned by this tool. Okay, this tool mentioned this into a 94%. Okay, this AI tool in medicine is developed as a decision support system. Okay, so decision support system means this interpretation, this top in the right corner, this interpretation is, this percentage is given to the medical experts. Okay, this will be passed to the medical expert. So the medical expert will come and he will see, since subdural is 94%, immediately he will treat the patient based on this subdural abnormality. Okay, so that's why this is used as a decision support system for the interpretation of head CT scans. Okay, because all these images are CT images, and this is based on machine learning. Okay, this tool is developed based on machine learning. Okay, so the merit of this tool, okay, what are all the merit of this tool? One is, since this is a AI tool, automation. Okay, automation is implemented. Okay, it is automatically detect and classify the pathological changes, that is disease patterns, automatically detect the disease patterns. So what is the usage of this automation? This will support the doctors with additional information, because the kind of percentage wise it is given. So the additional information is given to the doctor. That is the second merit. And third merit is, so what is the purpose of that? Since the doctor can have this additional information, he will take a quicker decision for giving the treatment to the patient. So that's what it will allows for a faster and more efficient interpretation for the patient. Okay, so these are the three merits when we use the artificial intelligence and machine learning algorithm in medicine. Okay, so now once again, I will discuss this. What is the difference between the traditional programming and machine learning programming? Okay, in traditional programming, you all know, using our system, we will give a task to you, then you have to write your program, then you have to give the data. Okay, you will write a program for the task, then you will give a data, then the computer will, using the program, it will analyze the data and it will produce the output. Okay, so this is the automation. So far we have understand that writing the program is an automation. That the program is suppose to find the student mark statement. Okay, to display the student mark statement, in what kind of process we are using, we will convert it into a program and we will feed the student data to the program. It will produce the output. That is considered to be the automation. Okay, but in machine learning, see here, for a computer, they are providing data and they are providing the output. Okay, this data is this way. Okay, this data is, this image is affected by the tumor. This image is, this is an image of an animal. Okay, that way it will give a data and it will provide the output. Then this computer will produce the program. Okay, it will produce the program. So here, no need to worry about the program by the developer. Okay, he will give the data and will label the data, then the machine learning algorithm, okay, it will support the system, the machine, to produce a model, otherwise it is known to the program. So this is known to be, the machine learning is known to be automating the automation. Okay, traditional programming is trying for automation, but machine learning is automating the automation. So here, since 2006 onwards, we are doing the research with this field in medical image field. So I will give a simple example for the, because so many researchers are, budding researchers are there in this workshop. You can make use of that. I will explain this concept of traditional programming and machine learning with our research. Okay. So in the traditional programming, when we start our research in 2006, that this is the human brain. Okay. In this human brain, okay, along this vertical line, this central line, here the brain have two portions, left brain and right brain. Okay, left cerebral hemisphere, right cerebral hemisphere. Okay, so there are two portions are there in our brain. Okay, along our long axis, brain is divided into left brain and right brain. So when you check this along this line, when you check this both the portion, almost they will be symmetric. Okay, almost they will be symmetric. Okay, see here, this is one scan along this vertical line. You can check here, check this place here, both the side you will have a symmetric structure. Even this place also, both the side you will have a symmetric structure. So this is the point, first point, where brain is symmetrical about longitudinal fissure. Okay, this vertical line, the name of the line is longitudinal fissure. Okay, then second point is these are all the point. Okay, these are all the facts used in a medical field. That's what I told you. No, data is a fact also. In my second slide, I show you data is a fact. Okay, so here one fact is brain is symmetrical about the longitudinal fissure. Okay, along this vertical line, if you check, both the sides will be almost symmetrical. Okay, then it separates the left and right hemisphere of the brain. Okay, this line will separate the left and right hemisphere of the brain. Okay, so this fact is with the normal brain. Okay, if suppose here, see, this is the tumor portion. If suppose any abnormality due to some tumor or due to some blood leakage, anything happen with the brain, it will affect this symmetrical. Okay, so now you check if along with this line, see here in this portion and all, in this place and all, they are almost symmetric. Okay, not 100% symmetric, almost symmetric. Here also they'll have some symmetric. Whereas when you come here in this left side you'll have a black gray region, in the right side you'll have a white region. The same right side you'll have a white region. So on seeing this image itself, the expert can say that, and medical expert can say that this image, the patient of this image, okay, is affected by some disease. Okay, he can say that because this is the fact they are using in the diagnostic process of the medical patient. Okay, so now in a traditional programming, what we will do, we will convert these things, all these ideas into, we have to transfer all this idea to our program. Okay, so in artificial intelligence, the system are known to be the knowledge-based system. So in the knowledge-based system, first we have to draw this center vertical line. Okay, we have to draw this line, but the line, we cannot draw this line in a center place. Okay, this line should be passed through this fissure. Okay, this line should be passed through this fissure. Okay, this is the original scan, it passed through the fissure. So for that, we have to define some coordinates, some bounding points, everything we have defined, and we developed an expert system. Okay, in previously 1980, 1990, 2000 time and all, artificial intelligence systems are otherwise known to be expert system. Okay, so in that expert system, here we have to define the search space and we have to give an initial state, goal state and some rules. Okay, so now you can imagine a robot. Okay, for a robot, you have to define, this is your start space, okay, and this is your goal state. This is your start state, this is your goal state, and you have to define some search space for the robot, okay. Then you have to define some rules for the robot, okay. Based on the rules only, it will move, okay. So in the same way, the expert system, you have to define, you have to give a value for this 4 descriptions. So we have defined for the brain images. Then for that, based on the description, we will write our algorithm. We write an algorithm. So this is our program. Then used to this, when we run this program using the brain images, then now this traditional algorithm will identify, if you are given a scan, whether the scan is a normal scan or diseased scan, it will identify. Okay. So for this, we have publications in Elsevier Journal, Computers in Biology and Medicine during the year 2011. Okay. Now see here, this work we have submitted in 2010, but it is accepted in 2011. This is for one kind of images, whereas in another kind of images, when we are submitted in 2008, this paper. Okay, this work we have submitted in 2008, but the foreigners, the reviewers are mostly in foreigners. They are not that much easily. They usually accept our papers. Okay, so for me it took 2 years to accept these papers. Okay, they keep on sending the review questions. Once again we work for that and we will submit our paper. And 2010 this paper has been accepted. Okay, so these two papers they are developed an artificial intelligence model for identifying the normal scan and diseased scan using algorithms, writing programs. Okay, then after then slowly the machine learning is involved into our research field. Okay, so in the machine learning, what is the concept of machine learning? There is no need to tell any fact or anything for that. Here in machine learning, you just define the feature of tumor. Okay, if a tumor means, if you want to identify a tumor image, just define the feature of tumor. Feature in the sense what will be the size, okay, how the tumor will be, in what intensity it will be, what will be its texture, what will be its shape. Okay, those ideas, okay, the points alone you tell me, that features alone you tell me. Then myself, the machine is saying, okay, the machine will develop its algorithm, it develop its model, then it will use it for identifying the tumor images. Okay, so that's what these 2 points, like writing the expert system, description, algorithms, and nothing is needed for the machine learning algorithm. They need only the feature of the tumor. Okay, so here this is a development of machine learning algorithm. Okay, usually machine learning algorithm involved with 2 phases. One is the training, another one is the predicting. Okay, so the training here, this is my images, input images. So I told you, for machine learning, automating the automation, I have to provide the data along with the output, that is along with the label. So this is my image. This image is whether in the benign tumor or malignant tumor. Benign is a single tumor, malignant means some cancerous tumor. Okay, so that way I have to define. If I give an input, an image, along with the image I have to label the image. Okay, what kind of tumor it is. Then next I have to specify. If suppose for benign and in malignant, what kind of intensity is related with the tumor, then how the edges will be appear, what type of texture will be available with that, what are all the shape of, what may be the shape of the tumor, everything. Okay, these are the some kind of features the programmer defined for the tumor, and he will hand over this to the machine learning process. Okay, so this is known to be the feature extraction. As soon as getting each image, they will try to extract all these things. Okay, then they will form a feature vector will be formed, because I already told you in data analytics, the data set you have to produce the data set in a concept of a tabular form or matrix form or in a vector form. Okay, so the feature vector will be, okay, this getting input, feature extraction, feature vector generation, this may be a part of data analytics. Okay, then when you submit this feature vector to this machine learning, there are so many machine learning algorithms are there. Okay, so many machine learning algorithms, they are based on the regression, classification, clustering. Okay, so many algorithms are there, so it will choose. Okay, here you have to carefully choose a kind of algorithm which will be support to achieve your goal. Okay, that you have to choose. Then if once the output is, we have to check the output and its accuracy. If once the output is satisfied, then here you can keep the model. Otherwise, once again you have to go to your repeat this process. Okay, so that's what training is, an iterative learning, because learning is not, we will not reach the 100% intelligence in a single step. Okay, so I have to keep on learn. Okay, keep on train it. Okay, so that is, it is an iterative training process, iterative learning process. So once that is a best model, once it reaches a best model, that model will be given for its prediction. Okay, so for the prediction, okay, now the model is available. So whenever a new patient is arrived, his images are given to, in the same way the feature is extracted, vector will be produced. Now the model will be checked and it will say whether this patient is a benign patient or malignant tumor patient. Okay, so this is the concept of the machine learning algorithm. Okay, so after that you have implemented machine learning also for our work, and one article was we developed an article based on the machine learning approaches for automatic brain tumor detection using here this feature data analytics. What kind of data analytics we did? Patch based feature extraction. Okay, patch based feature extraction and classification. So here this feature extraction, we are using a new concept, patch based. Okay, so this paper was published in International Journal of Biomedical Engineering and Technology. Okay, then recently, so these are all our publications during 2015-16 and all, but whereas during 2020-21 deep learning is emerged. Okay, it is considered to be the one of the latest technology in our research field. But because and the same way in Nature publication, you all familiar with this journal. Nature is one of the topmost journal in research field. In 2021 Jan, it published one paper on brain imaging, a review paper. There they said deep learning beats the standard machine learning. Okay, so that's what. Okay, we'll leave it. But I will say I'll show you what is the difference between machine learning and deep learning. Here in the machine learning, you will give an input and a kind of features. You have to give the instruction to the machine learning algorithm. These are all the features related with this image. Okay, for doing this classification. Okay, you have the labels you have to define. Okay, once you do that, then it will do the classification and produce the output. But whereas in deep learning, see here the input, you no need to provide anything. Okay, just to give the image. Okay, then feature extraction, classification, everything will be done by the deep learning. It itself it will do. Okay, then it will produce the output. Okay, so what is the role here? We have to carefully give the input. What? Okay, all kind of data should be provide to the deep learning. Then we have to train it. Okay, because feature extraction itself doing by the deep learning algorithm. So that's what in our the same in our application. Now the first two these rules are no need. And second, for traditional programming rules, no need. Then for machine learning feature definition, defining the feature for machine learning also no need, because in deep learning itself it will do. Okay, that is the big challenge nowadays for doing research with the deep learning techniques. Okay, so in deep learning techniques, there is nothing to do with this programming algorithm or anything. Okay, everything is available. Here you have to only work with this data science. Okay, data analytics or data science only you have to work with. Okay, so these are the some of the images. I skip it. Okay, so in the deep learning algorithm, there are so many concepts used with the deep learning algorithm, like activation function, optimization, loss function, regularization. So many architectures are available. Autoencoder, CNN, RNN, RBN. Okay, so many architectures are available. But here, the selection of architecture and objective function, everything is built in available, but they may be, that selection should be carefully done based on the data considered. What kind of data you are going to work, that you have to, based on that only, you will select all these things. Okay, so the data may be from a medical side, or data from a food industry, data from the agriculture field, or data from biotechnology, nanoscience, nanotechnology, anywhere, or a business data, anything you can take. Okay, but you have to concentrate on this data. Okay, so that's what data science. Okay, data science is nowadays one of the very popular field. So many people are trying to working with this, learn this and working with this data science field. Okay, so in this data science, it is nothing else but it is preparing data for analysis and processing, performing advanced data analysis, presenting the results to reveal patterns and enable the user to draw informed conclusions. Okay, so this is a kind of pre-processing, data pre-processing. You have to work with that before going with this deep learning. Okay, so once again I'll come to this, because deep learning is not my concern with this talk. Okay, I am doing only with this machine learning. So the machine learning here, you have to understand here. See, machine learning algorithm, you give the input data, give the training. Okay, during the training time, by selecting this algorithm, it will learn something from the data, then it will produce the models. Okay, now this model will be used with the new data for producing the output. Okay, so here 3 steps. Step 1 is it is learn from historical data. Okay, it will learn from the input data. Past data means historical data. Then it will build the prediction model. Okay, it will build the prediction model. So whenever it receives the new data, it will predict the output. These are the 3 main steps with the machine learning system. Okay, for any machine learning system, this is the concept. Okay, so these are the machine learning process. When we use this machine learning with the data science or data analytic portion, okay, here you have to first 5-step process. First you have to get the data, Then you have to do the clean, prepare and manipulate the data. So this is very important. Step 1 and 2 are very important, 1 and 2. Then after that, you have to train the model, okay? You have to train the model. Then next test the data, okay? Training, testing. Then same time you have to improve the performance of your model, okay? Improve the performances. Sometime at initial stage it can produce the performance up to 70%. It can satisfaction result only it will give. Then once again if you train it, it may reach to 80%. Once again if you train it, it will go for 85, 90, 95. Okay, so you have to try for 100% satisfaction. Okay, that will be happen with this improvement stage. Okay. So in this first data collection, okay, data collection is collecting data is the fundamental step of the machine learning. Okay, collecting data is the fundamental step. Okay, so in this you have to collect the relevant data. You have to collect the relevant data. So you have to first fix your domain. Then, but that you have to collect the relevant data. Suppose you are working with food industry and you are going to work with some agriculture based products, then what kind of product, okay, in a food industry, what kind of product you are going to develop, based on that related data only you have to collect. Okay, then only it will improve your outcome. Okay, that is the first step. And second step is data cleaning. Data cleaning I already told you, a simple concept is missing data. You have to know how to deal the missing data. Okay, in textual form and all, missing data means sometimes the entry may be missed. Okay, whereas in images it may be a noise. Okay, it may be a noise or contrast loss, anything that is known to be the missing data. Okay, that you have to know how to clean it. Okay, how to improve the quality of the images you have to know. Then you have to convert all the data into a same format. Okay, in a single format. If suppose you are taken the images, one image into JPEG format, one image into BMP format, one image into the PNG format. Okay, like this you cannot use. You have to change all the data into a single format. Okay, you have to standardize the data. Then after that, step 3 is in the data set. Once you're ready with your data set, you have to split the data set into 2 parts. Okay, why 2 parts? Because machine learning 2 phases are there. One is the training, another one is the testing. Okay, so you have to divide the data into training and for evaluating the performance. Training your model, evaluating the performance of the trained model. There you have to, okay, this is also a very important step. Okay, so first you have to collect the data. Okay, then you have to clean the data, then convert all the data into a standard format. After that, you have to divide the data set into 2 sets. Okay, one for training, another one for testing. Then training, what is meaning of training? Training is nothing else but learning start. Okay, learning space. Okay, so this learning starts with the training. There are so many algorithms are available. There you have to choose and you have to start your training. So this learning, this data set, it will use the data set and it will predict the output. Okay, once you satisfy with the output, you can stop it and you can produce it as a final model. Otherwise you have to repeat the training. Okay, so that is known to be the practice. Okay, that is, you all familiar with our suppose if you want to become a big sportsman, you have to keep on going for coaching. Okay, so likewise you have to train the machine. Repeatedly you have to train it to reach the final good accuracy of the model. Okay, so this is the training. Then model evaluation. So this model evaluation is here testing your data model. Once the training is completed, you can test your data model. Okay, whether it is with some real life examples. Okay, testing data set, you are divided. No, using the data set you can test your model. And finally, if once it trained and it tested means evaluated, now it is very perfect. Okay, then you can use this model for any prediction. But during the prediction time also you can improve its performance by tuning the parameter of the model. Okay, this is very good. Researchers can work with this tuning concept. Okay, because we cannot satisfy with. Once again you can tune the parameter and you can once again train the model and get a very good output with the trained model. Okay, so once everything is over, now you can ready with your model. You can go and deploy the model for real life examples. Okay, so these are the steps involved with the machine learning. So next is naturally, as a budding researchers, you can have this question, madam, how can I get a data set for machine learning? First, what is a data set? Data set is nothing else but collection of data, okay? Collection of data arranged in some order. Mostly they will be arranged in a table, row and column format, okay? This is the textual data arranged in row column format, whereas in these data are mostly in Excel sheets or CSV format, okay? But in nowadays, if you are work with this JSON field file format, then tree-like data may be popular with this, okay? With this also you can work for machine learning algorithm in JSON. There are so many kind of data are available. You are all familiar with that anyway, numerical, categorical, ordinal, okay. Then what is the need of this data set? Once the data set is prepared, okay, the image is prepared, then here the original data set, I already told this in the machine learning, they will be divided into two parts. One part for maximum part for training and some small part will be used for testing, okay. In the training itself, you will train the data using the algorithm. Then validation set is used to check your predictive model. Then test is used for estimating the final performance of your model, okay. There are so many popular sources are available for data sets, okay. Any kind of data from this Google data set, okay. This is the website. Just Google this name Google. You can get so many data sets from the Google site, okay. No need to go and produce your own data set. If suppose if you want to work with any plant-based information system, there are so many plants are available in Google dataset, okay, or tree-based datasets are available, or fruit-based datasets, animal-based datasets, forest dataset, satellite dataset, okay, and medical image data, everything almost in all the field data are available in Google. Okay, then you can just go to Google and Google it and find it, and you can download and use the dataset. Sometimes if you are creating your own data set, okay, in your local places, you have taken some images, and if you are creating your own data set, you can publish the data set in Google also. They are supporting that also, okay. So this is a good opportunity. You can make use of this Google data set. And finally, I keep in my discussion, mostly I'm using this select the machine learning algorithm, choose the algorithm, based on the algorithm, the model will be produced, I used to, okay. So now you have to know little thing about this machine learning algorithms, okay. Almost the time is 1 o'clock going to. Okay, there are machine learning algorithms are supervised, unsupervised, and reinforcement, okay. So in the supervised, unsupervised, and reinforcement, in supervised is classification, regression, unsupervised is clustering, reinforcement is model based or model free, okay. So in this, okay, this three algorithms in supervised, unsupervised, and reinforcement, you see this line, okay, this here, mostly they are regression, classification, clustering. Classification, clustering, okay, that concept only we will use with this kind of algorithm. Supervised means here with the data you will give some label, unsupervised only data will be available. So that's what mostly clustering is used with unsupervised. Only supervised regression classifications are used with supervised. Reinforcement is a concept of robotics, okay, based on some trial and error based, you will use this reinforcement algorithm, okay. They will be deal with this robotic control and all, okay. So there are three key machine learning algorithms are regression, classification, and clustering, okay. So regression is mostly used with continuous space, okay. So here you will try to fit this curve y equal to mx plus c, okay. This is the main concept used with regression. So once you fix this y equal to mx plus c, then the data, these are the data points. The data points above this line are considered to be one group, below this line are considered to be another group, okay. There are so many regression, linear regression, perceptron, neural networks are there. Then classification. Am I audible?
Audible, ma'am.
Then classification is mostly used with the discrete values, okay. Regression with the continuous values, okay. You have to be careful here, okay. If you are going to work with continuous values, go with the regression. If it is discrete values for the same kind of grouping, then you can go with the classification. Here the classification is finding curves, okay. Instead of y equal to mx plus c, here you will find this curve. This will support to classify the groups, okay. Then there are so many algorithms, support vector machine, neural network, naive Bayes, these are all the algorithm, okay. Then clustering. Clustering is grouping, okay, grouping your data point, okay. For that you will use a clustering algorithm. So here grouping, there are 5 groups are there, blue color one group, red color one group, orange one group, green one group, violet is another group, okay. 5 groups, the data points are grouped, okay, based on some concept, okay. Then there are popular algorithms are k-means clustering and agglomerative clustering, okay. So here already told you, regression and classification comes under supervised learning. Clustering comes under unsupervised learning. Okay, so this is the good picture to explain the supervised regression classification. Okay, unsupervised clustering. So in this regression and clustering work with the continuous data, classification is work with the categorical data. Okay, so this is a good picture explain this. So based on this, so many algorithms are available. These are the very popular machine learning algorithm. If you want to learn about the basics used with this algorithm, very good notes are available with the Java point. Okay, you can click and you can learn this algorithm concept used with everything, because regression you know, but you have to understand what is the difference between the linear regression and logistic regression. And what about this decision tree? Okay, what is the difference between decision tree and random forest? Okay, these are all you have to understand. Okay, but this is very simple only. Okay, for understanding this kind of algorithm, you just need a fundamental knowledge of probability, statistic, and linear algebra, and small coding knowledge ability, and along with some calculus, and you have to know the differentiation between derivatives of single variable and multivariate function. Derivatives, differentiation derivative. That's okay. This is simple knowledge is enough to understand those algorithms. Okay. Then after that, here for your application, you have to choose what kind of algorithm I can choose. Okay, instead of knowing how this algorithm is working, you have to know what is my domain, why I am going to use this. Okay, and you have that idea, then that will be support you to choose the algorithm. Okay, no need to worry about how this algorithm is working, in what way it is working. Don't worry about that. Okay, based on the domain, you can choose and work with this algorithm. For example, if suppose in my data, I want to classify them. My data belongs to group A or group B, just a binary classification. I can choose any one of this algorithm. Okay, you can very well choose any one of this algorithm. Okay, the same way, more than one group. Okay, suppose my data will be belong to group A or B or C or D. Okay, that is known to be the multi-class classification. If suppose you want to implement your application multi-class classification, you can work with this. You can select any one of this machine learning algorithm. Okay. Then regression. Regression is already I told you, how many continuous form. Okay, that for that regression there are the popular algorithms. Okay, these are the regression algorithms. Okay, then to check whether my data is normal or any outlier, then here these are some of the algorithm I can work with. Okay, so in this way you can select. Okay, then organizing the data. Organizing the data is grouping. Okay, my data is there. If suppose hundreds of students are there in a particular place, I have to organize the students. Okay, group the students in a particular way. Then clustering. The clustering here I can use this kind of k-means clustering. Starting from k-means clustering I can use. Okay. Otherwise, if suppose I want to develop an application machine learning algorithm to work based on the output. Okay, some output will come, based on that it will react. The best example is self-driving car. Okay, self-driving car and all, while in a real time only it will decide. Okay, what will be my next action, where I have to turn, where I have to apply my gear, where I have to apply my oscillator, everything. That is based on the trial and error multi-feedback loops. Okay, so this is about this kind of concept. I have to use this reinforcement learning. So in that way only you can select your machine learning algorithm. Okay, so first know very well about your data and your domain and what purpose you are going to use that data. Okay, based on the purpose you collect the data, then you come for this machine learning model. There you carefully divide the data into training and testing and choose the appropriate algorithm and try to produce the best model for the algorithm. Okay, this is the main concept of the machine learning. Okay, machine learning is over now. Deep learning is a next step, but my talk is over with this machine learning. Okay, so next time, if I time in future, we will see a kind of deep learning if need. Okay, so I finished my talk with this. These are some of the references I used. Okay, thank you.
Participants, it is a query session. If you have any